In modern manufacturing, the solidification process of metals not only determines the final properties of the material, but also directly affects the quality and reliability of the product. Today, we will delve into the key technologies of metal solidification and grain refinement, revealing how to enhance the mechanical properties of metallic materials by precisely controlling their microstructure. During the cooling process of metals, atoms gradually arrange themselves in an orderly fashion, forming crystal nuclei. As cooling continues, these crystal nuclei keep growing in different directions, gradually forming a grain structure. The grains are separated from each other by grain boundaries, and the presence of these boundaries not only shapes the microstructure of the metal, but also acts as obstacles to dislocation movement, thereby enhancing the material's strength, hardness, and ductility. The smaller the grains, the greater the number of grain boundaries, which hinders the movement of dislocations, and thus increases the metal's strength and ductility. This effect is known as the Hall-Petch effect. We can optimize the mechanical properties of metals by controlling the grain size. Therefore, grain refinement is a key approach to improving the strength and ductility of metals. So, how can we effectively control grain size? Next, we will explore several common techniques for refining metal grains. The first method is by adding nucleating agents. Nucleating agents act as grain refiners in molten metal, effectively increasing the number of nuclei so that more fine grains form during the cooling process. However, the tendency of nucleating agents to agglomerate in molten metal is an issue that needs attention. When these nucleating agents form excessively large clusters, they may cause uneven grain distribution, leading to surface defects such as feather grains or bright grains. In particular, if the size of these clusters exceeds the final thickness of the metal, irregular pinhole defects may appear during subsequent rolling processes, affecting the final quality of the material. The second method is to control the cooling rate. By accelerating the cooling process, nucleation can occur at more locations, effectively suppressing grain growth and ultimately resulting in a fine grain structure. However, excessively rapid cooling may increase thermal stress, which can in turn cause internal cracks in the metal. Therefore, in actual production, it is necessary to balance the cooling rate with other material properties. The third method is ultrasonic grain refinement technology. Through the application of ultrasound, the growing grains are disrupted, resulting in the formation of more and finer grains. At the same time, ultrasound induces tiny eddies and vibrations in the molten metal, breaking up uneven temperature distribution and promoting uniform grain growth, thereby creating a more uniform and fine-grained structure. Since no inoculants need to be added, this technology avoids the introduction of impurities, further improving the purity of the product and significantly enhancing the overall performance and quality of the material. Dayin Technology has achieved a breakthrough innovation in the field of aluminum neodymium processing. By combining the proton diffuser with aluminum titanium boron wire, the aluminum titanium boron wire acts as an ultrasonic transducer, capable of applying high-frequency disturbances to the molten aluminum and generating vibration effects similar to ultrasound. Through precise fine-tuning, the titanium aluminum triple points and titanium boron double points in the aluminum titanium boron wire are excited to resonate, thereby releasing tremendous diffusion kinetic energy and rapidly promoting the diffusion of these form points into the molten aluminum. This innovative technology not only effectively improves the efficiency of point formation, reduces precipitation and impurities, but also significantly enhances the uniformity of aluminum alloy grains, thereby improving the overall cleanliness and quality of the product. This technological innovation enables the simultaneous implementation of 3 advanced grain refinement methods on the same production line, fully leveraging their synergistic effects to enhance production efficiency and product quality, demonstrating Debon Technology's leading position in aluminum alloy manufacturing.